This is day 0 to day 2 with Kong and Kuma. I'm Austin Colley-Edwards, the Director of Data Platform here in my home and at FinTech Studios. So at FinTech Studios, we work with large, near real-time data sets, mostly focused around financial news and various taxonomies. We've been a user of Kong for some time and recently of Kuma. I've contributed a couple small features to Kuma, most notably the introduction of Helm as a deployment method. I'm sure we all know about Kong, but might not have heard about Kuma. Kuma is the CNCF Sandbox service mesh that powers the Kong Mesh product. It's built on top of Envoy, a modern reverse proxy created by Matt Klein, who's also giving a talk at Kong Summit. I'd suggest taking a look at his talk as well as some of the other talks around Kuma to get a broad range of use cases. I know Nikolai, Jacob, and Marco, who are Kong maintainers, are giving talks, as well as some Kong engineers and other Kuma users. So before we really get started, just a few notes. This is really going to be a high-level why and when of integrating service management into your stack. It's been tough for us to know exactly when to make the call to invest in this kind of technology. As a startup, we're constantly balancing new feature requests with tech debt, with other kinds of growth, sometimes making it difficult to pitch working on features that the business can't really see. And while there's a lot of flexibility within startups, at the end of the day, you really must provide value to your clients in order to survive. So we'll be using AWS and its lingo, but this talk applies to really all public cloud offerings. We'll take a look at an example timeline from what we're calling day 0 to day 2, defined loosely by engineering and product maturity within a startup. These terms have many different definitions, but we're really talking about day 0 as just starting to build, and day 2 as scaling and managing across many different clouds and client needs. So hopefully we'll answer the whys and whens of service management, what a service mesh is, and how to get started and involved in Kuma if you're interested. So as you work your way through building a startup, there are many different design decisions, tech investments, and business factors that shape that path. It's not always a linear journey, but there's always too many choices at each step. So this doesn't necessarily represent our exact journey at FinTech Studios, but perhaps is a semi-typical one. You might start by picking a cloud, getting some funding, deploying some simple apps to EC2 instances, using a managed service for simplicity. And come on, we've got the cloud credits. Then you start building out some more APIs, some batch jobs to work with the data that you've gathered, some serverless functions as well. And then as you build out that engineering team and practices, things like CI/CD, containerization play a big part in developer efficiency. As more apps are containerized, you look for a container orchestrator like Kubernetes, though there are always more clients asking for more features and more things to do. These clients start to ask things like third-party pen tests and security audits. Your CTO asks when you'll be able to leverage a multi-cloud setup. And come on, get more of those sweet, sweet cloud credits. And of course, looming on the horizon line are on-prem deployments and things like that. So in this loose arrangement of markers, we're somewhere between day 1 and day 2 at FinTech Studios. We've been running Kubernetes in production for over a year. I've left off service management from this timeline as it's often unclear where it fits. But hopefully we'll find a natural fit for it somewhere in here. So using that rough timeline as a base, we'll take a look at how our cloud has grown. Again, not exactly, starting from the beginning. So like we were saying, we started by finding a product in a market, building sporadically, getting it live. And at this stage, deployment and stability are not really priorities. It's really about getting something out there to show, and it can be really fun in a creative time. But you find yourself using things like managed services to reduce deployment and ops cycles, but they can be inflexible, expensive solutions. The guesswork causes a few issues, even with talented engineers, since it's not really clear what the end goal is all the time. And because of that, some features can take hold that rely on unstable systems. For instance, let's throw Neo4j on an EC2 so we can get some graph data. Here's a Node API for the website. Let's host it on Elastic Beanstalk behind API Gateway because we can do that in a day. We need hourly metrics. Let's connect some Lambda functions to our database. There's not enough time for automated service management. It's simple enough to use Route 53 as a registry. So everything at this stage is client and time constraint driven. And as you're building, you know the issues are there. But experiencing these issues are good. It's a privilege to wake up at 3 a.m. and read logs. So looking out towards day one, as we grow, the product or parts of it catch hold with clients. We can build out like that true product roadmap, which is a great thing to have as an engineer. And clients are asking us to build things for them or add new features to what we already have. And we start to push the limits of what's possible through our current tools and managed services. Along with this, people want buzz, you know, like we want to use the state-of-the-art AI and ML, which is both fun for tech people, but is also a good business sell. Nobody wants to buy yesterday's bread. So as we start to build out these more complex systems to meet client needs, we're more often faced with integrating them into our existing product rather than replacing older features. And priority is still 100% about keeping the clients, investors, people with money happy. But stability is really starting to matter. Deploying frequently and with confidence builds trust with users. And this can also be like a really fun and creative time. For instance, there's a bit more time to invest in tech, like containerization of your services. CI/CD is a big one. We added a big data cluster, some more ML models behind their own services, enhanced monitoring with Prometheus. But along with this, there are some challenges. Observability is tough and easily costly. Like, who knew CloudWatch was so expensive? New tech starts to overtake this day zero tech, even though this legacy service is still needed. Deployments now happen across many different platforms, and the frequency depends on how easy each one of those platforms is to use. So say this EC2 instance for the Neo4j servers almost never gets updated, and we start to touch them just less and less. We also find that the solutions that we've found, like Kubernetes, create more complexity. You know, even though we've standardized computing with it and made great use of CI/CD tools, there are so many new things that it's a lot to wrap your head around all at once. And we cannot migrate all of our legacy systems into the new patterns because the business requirements don't allow us to spend all of our time building the perfect cloud. So also, while all this is happening, clients start to use these new and existing services in different ways. We've gone from selling a web app and variations on that to selling API access, data feeds, and other custom solutions to clients who need them, which is really crucial for growing the business, but creates some ops difficulties for sure. So as we look towards day two and our solutions become more stable, we know we need to solve some serious scaling issues, among many others, in order to keep moving forward for a variety of clients with different use cases. So while we're not personally here yet, these ideas have been floated by many clients and we know it's coming. So clients are still our top priority. If someone's paying for it, we can build it. At this future stage, there's like so many different needs to support. While our product direction is relatively stable, we now have on-prem and hybrid deployments. We've started toying around with multi-region and multi-cloud setups for resiliency and cost benefits. Security is non-negotiable, and our web of connections is more complex than one or a few people can reasonably keep in their heads. So we're hoping this will be fun, but taking a look at these initial designs is daunting. As we've built up our cloud and services, the cracks have really started to show, specifically around connectivity. So it's really hard to permission, observe, and just see what's going on in our many services. We've got this complex network of firewalls, low-level routing policies. Perhaps we're using a central API for authorization or something like that. Maybe we're using tons of custom code to manage these connections, smart clients. So as an example, Say this Neo4j server on EC2 stops accepting a portion of incoming traffic, which at this fictional future point hasn't been touched in 4 years. Since it's so deep down in the stack and so old, finding the cause may be nearly impossible, and even pinning it down to Neo4j being the cause might be really hard, especially if it's only affecting, say, client C. So at this point, like, hello again, 3 a.m., but this time there are so many more logs and services to read through and debug. So who's talking? How do we manage all this? Really, what's going on? So talking about the future at FinTech Studios became more and more stressful. Unknowns built up. It became hard to make design decisions, and progress stagnated. We knew we needed to do something to manage our ever-growing services, the legacy infrastructure, and prepare for the onslaught of future needs as we scale our cloud. So I'll now walk through a little bit of how we approached this connectivity issue applied to this example scenario. So if we go back to day one, the first thing that we did is make continuous deployment with Helm rock solid. We had already invested in GitLab CI/CD as our CI platform. So Helm was incredibly easy to set up with that, and it is with many other CI/CD platforms out there. Helm helps manage the versioning, upgrades, rollbacks, reproducibility, and customization of deployments across all of our environments. It's focused on UX, which makes it a great starting place, especially as we start to move more into the infrastructure as code declarative mentality. There are Helm integrations out there for other systems in that space, like Terraform, and it's got that out-of-the-box usability to spin up almost any cloud-native software, including Kong for Kubernetes and Kuma. And with this array of software, we can start to think about replacing some of our managed services. So thinking about replacing some of these managed services, the first one we picked was AWS's API Gateway. We had already had some negative experience with the API Gateway from AWS. It was difficult to update both by hand and with automation. Kong, which we've been looking at for a little while, is way cheaper. The plugin ecosystem and flexibility it affords works well for our changing needs. Having a native Kubernetes ingress controller for the short term made it integrating with our existing cluster and Helm deployments a breeze. And Kong has really given us that external control we needed and allowed us to expose some of these Kubernetes services securely. But it's also left us with a few issues. For internal communication, both within these clusters and within our cloud as a whole, it's still difficult to secure, authorize, and observe communication. We still find ourselves relying on custom authorization code for connecting these services. The number of services continues to grow. So it's really hard to imagine how we'd expand this to client data centers without replicating our entire service stack. So going back to that Neo4j issue again, it's still buried so far down, it would be difficult to address if the failure was reported somewhere higher up. So we knew we needed a more service-oriented solution for an individual service basis because we didn't have the ability to keep track of each one of these services. So at this point, we started investigating some buzz we'd heard about, but never had the time to dive into service mesh. So a service mesh aims to tackle the entire connectivity stack of services, which is exactly what we're missing. The core of this mesh is a network of reverse proxies that run alongside each service and connect with each other, paired with a central source for configuration, monitoring, policies, tracing, etc. So these are typically referred to as the data plane and the control plane. So instead of connecting directly between each app, it's offloaded to the data plane in a consolidated app agnostic way. So when we were looking at service meshes, we didn't just consider Kuma, but the wide variety of implementations out there. One of the things we found was that many of the current options are built specifically for Kubernetes or with Kubernetes in mind. Kuma, on the other hand, targets all types of environments without sacrificing that native Kubernetes support. So as we'll see, this was especially exciting for us to tackle our legacy infrastructure, as well as being flexible for those future semi-unknown requirements. So going back to our infrastructure with Kong as a gateway, we were able to integrate Kuma starting just with our Kubernetes clusters, all with the tools that we're already using, like Helm for automated deployments. We're then able to define exactly the connectivity that we need without having to dive into yet another set of complex, low-level policies that exist in Kubernetes that would have eventually led us down a similarly complex path to our AWS firewalls and security groups. So that being said, and going back to the complexity new solutions add, Kuma and other meshes offer so many features, it's difficult to really choose what can help a team and a business. So some of the things that we found really helpful are things like MTLS, so we don't have to provision and manage certificates, traffic permissions for high-level authorization between these services, health checks to keep track of individual services, Prometheus integrations and Grafana dashboards to visualize what's actually happening in here, traffic logging and tracing for even more insights when things go wrong, and importantly for us, native support for Kong as a gateway into the mesh. And that's really excellent because Kong is such a core part of getting into the mesh and our network that it's great to be able to have native support. But Kuma also doesn't sacrifice that and doesn't lock you into Kong and is compatible with many other gateway implementations. So that solves our Kubernetes issue, but because Kuma is truly universal, instrumenting our connections to existing legacy services is also possible. So for like EC2, it's possible to run the Kuma data plane next to our Neo4j server. The ECS cluster that backs AWS Batch can run Kuma in a containerized form. And then we can apply kind of the same high-level policies that we do for our Kubernetes services to our entire infrastructure. This becomes quite powerful because we can finally unify the view of our services in a cost and time-effective way and can be confident that this architecture won't have to dramatically change as we build the future. So now looking towards this future scenario, this multi-hybrid cloud becomes much easier to imagine with the use of Kuma to individually monitor, secure, and connect our services while using Kong as a gateway between these different environments. We can manage fine-grained, high-level traffic permissions in largely the same way across really any scenario. And when we think of on-prem deployments now, we can try and keep them as small as possible without trying to replicate our entire infrastructure with each client that needs on-prem. So going back to that observability, we now have some really insane observability into failures and tracing between these services. So for Neo4j, one last time, say it starts dropping a portion of requests again, Kuma will know, whether it's from health checks or metrics or other indicators that running a data plane gets you. The root issue almost presents itself instead of having to be painstakingly found. So wrapping up, some of our biggest takeaways from this journey are features never die, we'll never have enough tech time as we'd like to, and the product is always growing. We also want everything as declarative code as much as possible. Investing in CI/CD is the basis for so much of the automated observability and management we have. And then investing in API and service management is not always possible early on, but having a plan in place and knowing when to make that investment is key to avoid a lot of less than productive days and sleepless nights. So with that, I'd like to invite you to try out Kuma if you're in a position to do so. I hope to see you around the community, and I hope you find it as full of nice people as I do. And thank you again for the opportunity to speak for Kong and the people at Kuma. And with that, I'd like to invite you to the Q&A, which will start now.